All right. Good morning, everyone. Thanks for coming to this talk this morning. And finding this place. They moved us at the last minute over here. Well, the topic of my presentation is fun with Lambdas C++ 14 style. Have you had a chance to look at the slide material before by any chance? Some of it is actually all of it is on my blog. So well, okay, that's you're not. That's great. That's great. So I hope you'll find something really interesting today. So shameless plug. I was going to start with, but this is not responding. I guess it's low on batteries. Give me a second here. Apologize for that. Turn this off. Sorry. Let me start over. Yes, awesome. So I've been, if you like find out, chances are you will today. Might as well like some of the other stuff I have written. So this is actually one of the series that I have been writing on fun with lambdas, and other two. This is pretty much going to be the first presentation. I think the most interesting one. There are other two and more coming up on the blog over here. Might want to check out the wiki book if you're interested in idioms. Most of my experience of functional programming, I don't really claim to be a functional programmer, at least so far. I would really like to, but I don't. I think that's probably because C++ adopted lambdas pretty recently. But I did some work over the years, and I have a talk today this evening at 5 o'clock on RX4DDS. That's also functional programming. If you like reactive programming per se, then that's something you would definitely want to check out. And some of the work I did a few years ago on C++, these two are both C++, quite a bit of functional programming in it. So now you know what you're really getting into. So bear with me. Well, in a functional programming conference, I mean, you don't put up slide like this, but in I think C++ community, I kind of feel that how much important all this stuff really is. Because I mean, these are the conferences that people go to, like professional developers, and they pay $1,000, $100 to go and attend all functional programming talks. And then, I mean, why would one do that? And these kind of conferences have increased quite a bit over the years, because I guess people are starting to realize the programming languages, tools, and in general there is a more awareness of why functional programming matters. We'll look at that a little bit, and this talk is not about why functional programming is great. We'll get down to code directly in C++, what it means, and look at some really interesting C++ 14 lambdas. So lambdas are in C++. Yes, that's an old story now. C++ 14, which was I don't know. I believe it has been ratified now. Yeah, I'm pretty sure it is. So what you see here is a very quick overview of lambdas. How many of you have seen or used lambdas in C++ before? Okay, about half the crowd. So I will go through I see some functional programmers here, I mean F# and others. So I will go through the syntax of very basic C++ lambdas. So I have here a function, absolute sort, and it takes a pointer to a float, essentially an array of floats, and the number of integers, the number of floats in it are here. So that's an array number of floats. So I'm going to call the standard sort function, and this is the range that I'm passing in. X and x plus n is one past the last element. That's the STL convention. So that's the range I want to sort. Well, I want to compare the floats, right? But I want to make sure that you just use absolute value only for that. So I pass in a lambda. So we'll talk about that. That little thing over there is called capture. You can capture things in your environment. We'll see an example of that. And each time this function is used, sort will pass in two parameters, right? One float A and B. And now it's basically asking, well, I see these two values, help me decide which one is smaller, which one is not, So that's what we implement right here. And sort will do and go and do its stuff because, that's all it essentially needs. So any questions on the basic, how lambda syntax looks like in C++? Essentially,
What exactly the brackets means on the syntax?
which brackets? These?
Yeah, this one.
Right, so these are for capture. So if you want to capture some state that's available in this context, then you will put the variable name inside this. For instance, if we don't want to capture anything right now. We'll look at examples of that pretty soon. So it is essentially, this is what makes the lambda a closure because it is going to capture the environment. Because without anything here, this is as good as a simple function that just given two parameters returns a Boolean value.
Yeah, but that's what we intend to use this
Yes.
for. We don't need the brackets right now.
Oh, well, we are going to need that. We will see that pretty soon.
So right now it is just a kind of a comparator, right?
It's just a comparator
Yeah.
right now.
Right
Yes.
now it's just a simple SQL comparator. Okay.
Yeah, you don't have to specify all those return type and all those all that machinery that you need to specify with comparators. But here we just specify the go ahead and start doing.
So can I say that the function we have used within the sort is putting in the context of the sort itself? Because using of that function, which is kind of finding out the absolute values, right?
Right.
And we are putting that into the context of sort. Right?
You could say that it is to the extent you can say that when you pass a parameter, you are putting it in the context of the function. It's comparable,
Okay.
If you think x and n are in the context of absolute sort, well, that's exactly what's happening. This lambda turns into an object. That's not the point here, but it's essentially a function object. That's the mechanic of this. And simply it's a third parameter to the function. So 1, 2, and 3. Yeah. The notion of yeah, go ahead.
You said third parameter, 1, 2, and 3. What's the one? What is
The first parameter, well, it's probably hard to see
sorting. Oh, that
from
one.
sort. Yes.
One other question. You used the word closure. Can you
Yes.
tell me what generally lambda and closure is?
Sure, I'm going to touch upon that, in the middle of the talk.
Awesome,
So,
okay.
yeah,
Thank you.
just few more minutes. Any more questions? So let's see how, I think the understanding of how lambdas are essentially function objects helps for C++ programs quite a bit. So here I have a very simple comparator class, and it has a float a, and I have a comparator constructor which takes an x, assigns it to a, that's all. And there is a function called compare. It's a member function, so it takes only one parameter and it will compare with its state a and b, and it will just return bool. So we're going to transform this into a lambda, one step at a time. So you'll see that it is essentially a class that expression that you saw gets boiled down to. So an array of 5, and then this is the variable, float a. I get a comparator that's going to capture that, it's going to save it. So f now has 3 values, 3 for the a, and it's just going to print out in true false whether how those members compare, and we're probably going to get some false and then true, right? Let's do a transformation of this. Let's get rid of the function compare, and let's call it operator bracket, right? Essentially a parenthesis. This is the function call operator in C++. You can overload that. So now instead of calling compare, I'm just going to call f item, and it just maps directly to that one. So you can, that's what actually compiler does. It's essentially a overloaded operator like that for that's what we are writing in Lambda. Well, now strictly speaking, we don't even need the name here. The comparator. Why do we need that comparator com? We can totally get rid of that. But of course, C++ will need some name, right? Eventually, and a type, because that comp was serving as a type and a name. So the compiler now has to synthesize that automatically if we are not specifying that. So that's what the next step will do. So you can get rid of the earlier part completely and instead replace that line, this part, that line with this. So all the strike through material, the text is basically replaced by this. So when compiler looks at this, it essentially creates a type, which we don't know what the name and the type is. It captures it. Here is the first use of that, by the way. So we have to capture A because it's going to use A over here, right? And this A is essentially as what we saw earlier, which is essentially some state inside the object, and that's it. And because this time the function is going to be a single parameter, to return comparison, it needs to capture half of it, and what you're comparing with comes later on. And that's how the lambdas get essentially transformed. Is this helping?
So I was confused. Auto F. What is the type of F? I guess. I mean,
It is
underneath.
some unpronounceable, never look at type, essentially.
Okay.
You can get the type of it using Dickel type, but ideally you should never need that type.
Normally, do you normally store, like you're storing right now the lambda, right?
Mhm.
The closure object, you're storing into F, right?
Mhm.
And you will let him use F. Normally, is that use, normally because people do that, I don't really understand. Or they're just going to define it right there itself
Yes, that's the point. You define the
And use it
lambda right
directly?
there.
and use it directly, right? Like what you do for sort, right?
Okay, yes, this is more explicit here. I'm
Right.
splitting it into two steps, that I'm creating one, assigning it to F, and then I'm using it later on. You don't have to do that. You can just put it right where it's used, like for instance, sort. I mean, this particular one won't work with sort because it takes only one parameter. This is a simple example to show how it works. So that's the point. That's the capture
So-
essentially.
I mean, from here it looks like it's kind of a function pointer. A function pointer and a lambda.
Excellent point, but it is not. So I'm really happy to that you brought this up. This is where you can start observing how it's different and a lot more powerful than a function pointer. The earlier example we saw, it didn't capture anything.
Yeah.
It took two parameters. So you could in theory write a function up there before main. Just write that, use a pointer and go with your business. Here you cannot do that because it is capturing something. And this capture is essentially making an object, right? It has its own state, and a regular function doesn't have its state. I mean, there are statics, but that's not the point. By defining a function, pretty much a function that has state, you can think of it that way. It's like weird of thinking actually, but I'm defining a function that carries state with it, whatever you pass it. But you cannot do that with a function pointer, right? You have to have an object that has state, and then you can perhaps use a pointer to member function and whatnot, and that's just ugly. So the main difference is you can capture values right in the context. I think that's the most important part. So this A is available in this context, right? It just captures that, keeps it with it. And this facility, you will see, will really go into it. It's going to get pretty nasty, I would say, after a few slides. And how this capture is really sort of mind-bending, and that's what makes it really powerful, I think.
Can you capture something more than value? Let's say your argument is array, and you capture array,
Mhm.
that compare, let's say, element by element or whatever, some
Yes.
element.
Yeah, anything that has an address, any variable is
You call
a very
it
business.
structure, whatever, data, structure.
Complete
is the
this.
verb. Structure.
A structure.
Can be
Well,
structure A.
Yeah, I mean, if you had a structure, foo, and an instance of it over here, and you just use that variable name here, then it just captures it. It's going to make a copy of it. It's not by reference.
It's like the object, everything which can be inside the object can be
Right.
used.
Right. It is just like you're passing in that variable to a constructor of an object. by value. There are ways to change it by reference, other things, but in this syntax, it's doing it by call.
Suppose if that object which is getting captured, if it goes away, like you deallocate or something like that.
That's not a problem here, because at least in
Is
this,
that doable, or it takes care of it, or it allows us to do those kinds of
excellent point. Actually, in most other programming languages I have seen that support lambdas, they are often garbage collected, and that's why when you capture here, it automatically extends the life of the variable, right? The object that you're referring to. So even if you run out of, if this was a function and you go out of scope, it's still going to keep a reference for it. So the capture automatically extends the life. That's the way to think about it. But here, A will be lost. This specific A will be lost, but a copy of it will remain.
So if you're having pointers, then would it be dangling there? It sounds.
If you capture a pointer, yes, that's a
Okay,
bit valid.
okay.
Unless it's a shared pointer, which will be
Makes
referenced
sense,
down.
okay. It's complex.
One crazy question.
Mhm.
It makes sense to have a lambda without arguments, like the bot. You do
Does it
something
make
like
sense?
whatever, initialization, do something
Mhm.
with the object inside of this function, and you don't take arguments.
I think
But
yes,
You have like the hardcore behavior.
It-
to do.
it does make
It's
sense.
used somewhere, we don't use the underscore stuff.
Okay, so your first question was whether a lambda without any arguments makes sense.
Yes, that's the main point.
That's definitely not the common use, but I see a few uses of it. For instance, you could initialize a constant STL container. For instance, you have a const vector, and you have to initialize it because later on you don't get any chance to initialize it. You could define a lambda that does some computation, produces a vector as a result of it, call it right there. So this function defines it, and you just put this bracket right over here. Now you define and call in the same statement, and I guess that would be one use where you don't pass anything to the lambda. It's just function body, inline function body.
It can be done with simple toggle, what you capture every time. Don't simple argument, every time you call the function, it toggle the object and that's it.
Mm-hmm.
For example,
Yeah.
So,
Okay.
Sumant,
Yeah,
one question.
sure.
How do you look at it, the performance using lambda and without lambda?
I want to say you shouldn't notice anything, absolutely anything, because as we just saw, when you create a lambda, you're essentially compiles it down to a class like that with a type that is weird, but that's it. So you have to ask, well, if I use a class here with a function like that, is this going to be any different performance? No, it's essentially the same thing.
Okay.
You have a syntactic sugar on top of something wordy,
Okay.
very verbose, otherwise. Yeah, so no performance penalty. They wouldn't accept a feature that kills performance in any way in C++.
So it basically reduces your the programming effort and doing a complex stuff a very easy way. It's just that matter of putting a few line of codes and it can handle complex situations.
Yes, yes.
Yeah.
You don't have to leave the context of your code. You don't have to go all the way at the beginning of your file, define a function, come back, and then do all that stuff. Maybe declare and define all that stuff that C++ forces you to do and drags productivity. You don't have to do that.
That's it.
But there is a lot more to it, like that. Any more questions? Okay, moving on. So here is basically we touched upon most of these things. So lambdas are anonymous functions, right? I mean, they don't have any. They are written exactly in the place where it's needed. We saw that. They may maintain state. If it captures something, well, it may maintain that state. It can be passed to a function and can be returned from a function. So it's like just any regular object for that matter. And this is where it starts getting very interesting and powerful. it deduces return type automatically. We didn't really write any type if you notice in the earlier example. Maybe we did in a couple places, but not everywhere. It deduces return type automatically. So that's very powerful. And in C++ 14, you don't even have to specify the type of your parameter. When you say auto, it's essentially you're saying, well, essentially it's a template. So B can be any type, depending upon how you call it. If you call this lambda with an integer, well, B will be an integer. If you call it with a float, it will be a float. So it will just deduce its type automatically as if it has a template. You know, the operator, function call operator is essentially a template, it just figures it out. Of course, this body should make sense for that type, but that's just usual template business.
So,
Yeah.
can you explain bullet number 3, the third bullet right now?
Right.
Scope.
Yeah. I'm sorry, I skipped that somehow. So the example we saw earlier, right? It can, the lambdas can, well, I should say closure is when, you know, this is a f. I would say is a closure. You know, this expression in red box is a lambda. It is a syntactic structure that you write. It is the same as, you know, like a class. Class is a syntactic structure, but class is not the same as object, right? Object is what exists at runtime, and class really doesn't exist at runtime. Some languages they do. Similarly over here, this is what you write. You write a lambda, and at runtime, the program will create instances of it. Well, now if it has a capture, if it has captured some state around its context, is going to be a closure, because it's what you say is that it closes over this thing, and it's going to say, well, somebody just said I have to capture A. Okay, I see an A over here. I'll keep it with me. That's it. So this very fact of, you know, capturing something makes it a closure. I think if it's not that, then it's just pretty much function delegate or function pointer. But capturing something is the most important piece for Lambda and its uses. I think that was, yeah.
So in the next part, where you said the generic one,
Mhm.
so is that basically a templated class? That's what's creating?
This one?
No, next line. Sorry, next slide, the last one.
The next slide, yes. The next one was auto.
The
So,
templated class.
yeah, it's not a template. It's a template class.
It doesn't know what type of-
Yeah, it's a template class because it has to. I was thinking if it's a template operator, but I think it's a template class. Yes.
Oh, okay, so it is okay.
I have to double check. Is it a template operator or
No, template class or not, because it doesn't know the type, right? You're not enforcing the type.
yeah? I think it's a template operator because the method parameters, the type of the parameter is used at at different places at different point. So I'm going to say, that's a good question. So I mean, one alternative could have been that you just make the operator template, or you could make the whole class template each time.
Right.
So yeah, it could be done either way. Maybe that's, I don't know.
It could be a class, right? Because you're storing the state, yeah, the state.
Right.
Yes, if the state changes, then you have to have a template class.
Yeah.
If it's not, every time if the capture is of the same type, then compiler can, well, okay, do an optimization. I don't know if you really optimization, probably not.
Okay.
So, yeah. But I tend to think, it's just template the class for the state.
Can we also use the auto for the argument?
What again for the argument?
For the argument, like here B, can we do the auto and password?
I'm sorry, I'm
We use auto for the
Oh.
an auto?
for the-
Yes, yeah.
With 14.
And, yeah.
With
C++ 14 only.
with C++ 11, no. But C++ 14, yes.
14, okay. All the way.
Yeah, we need to let us
And
combine.
another question, can we combine the lambdas and template to make the template to generate the lambdas?
Make the template generate lambdas?
Yeah.
Yes, absolutely.
Okay.
Yeah. Yeah.
No, because,
Yeah, I mean this could have been this whole function could have been inside the template
yeah, something.
and float, let's say it's all T. So, well, the compiler will create the right type every time.
Okay.
You said that the closure captures a value or makes a copy.
Mm-hmm.
Does that happen at the point where it's declared or down lower where it's actually applied or? I mean, because A doesn't change in between those 2 points,
That's
for
right.
example.
Mhm. It happens when you create it. So by this statement, you are declaring a lambda and creating an instance of it. So this is where the value of A will be captured.
If this is a copy and we change the value inside of the lambda function,
Mhm.
the original object,
No, it's not going to change the outside.
that's the design behavior for lambda?
Not every time. You have to
You
explicitly
can
opt in
give the
for that.
point to solve it if you want to.
Yeah, you have to opt in a sense. In this particular case, it's not going to change because it's by copy. If you want A by reference, then you just add a reference
Yeah,
before.
okay.
Now it's a reference. Any questions on these? You know, did I answer your question about lambdas and closures?
No.
No.
Yeah, I'm just gonna understand what's the, with the context of C++, again, what is the closure of this thing after that? I mean, the same thing?
I think I have to go back to this, and we will see more examples, but this is probably the simplest example I have of a closure. So when you capture something within your context, you know, context is sort of heavy word. I think it's in your scope. It is just in your scope, right? And then that's what makes it a closure, because you just closed over this. You know, in general, what happens is, you know, it comes from functional terminology, right? You don't have to specify this in most programming languages, actually, that support functional programming. It just looks at the body, and well, it looks, okay, there is A, I don't know what A is, it looks up in its scope. I don't know what B is, it looks it up and, you know, finds it out. But over here, it's just a parameter, but you know, in other programming language. So, and it figures it out automatically. So compiler is, I guess, a little smarter, or you know, because it has only one choice of keeping it around. And that's what makes it closure, because it automatically keeps A and B or whatever parameters around that you may need later on. So some other examples might help you with that later on. Well, I should definitely thank who knows? Do you know who this guy is? Douglas Crocker, that's right. So he's probably doing this presentation right now, you know, to about 200 people. So I was in one of those presentations, and he did, of course, was JavaScript, and I really liked his slides. I stole his slides and turned them into C++, and that's what we're going to see rest of the talk. Essentially, yes. I mean, that is just, you know, at some level, simple cannot be simplified further, and it's like, no, I have to take this and turn it into C++. The funny thing is, well, it's JavaScript slides, and you'll find 1:1, you know, correspondence between C++ and Java code. I mean, that's weird. JavaScript is a dynamic language, you don't specify types and all those things, and here we're talking about C++, how is it going to happen? But C++ 14 with auto is so expressive that you can in fact do that. That's what we're going to see. Okay, so let the lambdas begin, and may the fun be ever on your side if it wasn't already fun so far. So, well, that was an answer. But anyway, so here is, you don't really have to write, but you know, just start thinking about it, you know. Write an identity function that takes an argument and returns the same argument. So, a lambda that takes a parameter, and when you call it, well, you're calling this, right, and this is like a function call, returns. I mean, it's really, really simple. I mean, we will get more, more into it, but a function that returns its argument. So here it is. Identity, it's a function, and takes some parameter x and returns x. That's it. You don't have to specify any name as such, you know. You can have this body of code with inside any other function. You don't have to declare it at the beginning. But yeah, any questions on this so far? Extremely simple.
What this is useful for?
For talks like this. Very useful. Yeah. Yeah, we'll see. You know, so identity, okay?
It has uses.
Yeah.
Instead of
It
a
does
bunch of
different
functions,
things.
for
I
example.
believe so. I mean, I didn't want to go, I don't know, all the functional glory of identity function, but because I'm still learning. But yeah, it has functions.
Yeah, but you always can use the argument instead of this function.
You may have a situation where you need to pass a function in, and you
Okay.
want the function to return the parameter that's going to be there. In other words, if you were writing it yourself, you're right, that's why you still it. But you may have already a framework.
Okay.
And the framework is saying,
Okay,
I'm
that's
going to pass you
valid
a
argument.
parameter, and you need to pass me what you want, and what you want is the parameter. So you need this.
If you've got something that takes a transformation function,
Right.
and the transformation you want is none, then that's
Use the other
your transformation function.
Yeah. I mean, when you turn it into a lambda, you're basically saying, well, don't compute this right now. You know, you may do this later on. This is some computation I'm passing in. You may or may not need it. You may or may not call it, depending upon what algorithm it is. But whatever computation is there, it's up to the function that decides, well, do I really need this? And that's, you know, we were getting into lazy execution and those kind of things, which I find pretty interesting.
I've actually used an identity lambda in real world Dev.
Okay.
I had something that took a matrix of arbitrary dimension and different matrices for different transformations, common in a lot of scientific computing.
Mm-hmm.
And in this case, I included a case where the transformation I needed was the identity transformation. And, well, it's a lot easier than actually doing, you know, the identity matrix of an arbitrary size for templates. So, just saying, it ended up working out really well. And client can handle it now, so. At least the Git branch could handle it, so.
Okay, another function, right? Well, three functions actually. Add, subtract, and multiplication that take two parameters and just do the right thing, right? Add, subtract, and multiply. That's it. That's also pretty good. So auto add the two parameters, return x and y, x plus y. And by the way, don't forget that we can still write a function like this. Of course, that has to be outside, sort of global or some namespace or what have you, and specify types. You know everything, but this is absolutely not out of reach. I mean, this is still everywhere, every place where you can use this, you can use this also pretty much. I mean, this is int, but first question.
Can I do a specialization on the types? So for example, if I want to add a subtraction, and for floats I want to do something different.
Excellent question.
And
Ta-da! That's what you will do.
that's this function,
Yes.
not a lambda.
Well, in this specific case, there is no capture.
Okay, you're right.
So
Okay.
this is sufficient, where you need only integers.
And so the compiler will tell me the difference between those two? It will allow me to do that?
Uh-huh.
Okay.
Yeah.
And then is there a way to enforce the x and the y to be the same type and having both autos? Like in this example, they can be different types. Different types.
I think you probably have to do
Nothing I'm aware of, but
things like, I don't know if it will work, but I have an idea. Instead of the auto, we could perhaps say decl type of x. So it figures the type of x.
Oh.
It only depends on that. I don't know if it really says like, okay, I will reduce the type of x before trying to reduce type of y. But
Static assert work.
Yeah.
static what?
Static assert.
Static assert, but that's like, well, fail if it's not the same. It's not like continue and just make me the same as the other guy.
It doesn't do the conversion, it just fails.
Right.
Yeah.
Yeah, that's,
Well, I guess depending on what you want.
I mean, I know that the decal type works if you want to force the return type to be the same as X or Y.
Mm-hmm.
So I can't see why it wouldn't work for the parameters, but I've never tried that.
yeah, it's just, okay.
How would you use decal type to enforce the same types? I didn't get
You would write, instead of auto for Y, you would write decal type
Okay.
inside bracket X. So essentially, whatever the type of X is, make me of that. Okay. So here is a slightly different identity F function that takes an argument and returns a callable. So this is something not the same as we saw earlier. So it has to return something, IDF, and when it is called, brings 5. Okay, there are two separate things. It's not. I'll give you like a few 15 seconds to think about it, how it's different, and then we'll look into the
These are
source.
nice.
Yes, it probably has to capture something, the argument. Yeah, that's a good point. So, but before using lambda, I'm going to do it the old-fashioned way, really verbose and annoying way. Here is identity f, the top level function, right? And it takes one argument. That's why we have auto x. And inside that lambda, we have a class inner. This is going to be good old C++. There is a state variable, x is a member, a constructor that takes I, assigns it to x, and pretty straightforward, right? It's just simple function object and just and we return inner x. We create an object of it and return that. So if this object, the whole thing is called, right here, which is this function, we'll obviously we'll return x and give you 5. Make sure you are convinced that this will actually bring 5. Sure? Want me to go ahead?
So you created a class within
Inside
auto, and it's a closure object. Identity equal to
I'm not convinced.
Okay. I'll get back to you. Why not?
Because this constrains your type to int.
Good point. Yes. I don't want to go into that. Let's just say I want
I
auto
mean, if you
int.
templatize the inner class,
Yes. Yes, absolutely.
That'll solve it.
Yeah, that's correct, but that's not the point I want to make here. I just want to keep it simple because I don't know if you can create a template inside the function. Probably not. But you can create a class.
well, you can do a template inside now.
Okay, can
Because
you?
of C++
That's good.
11.
Okay, that's I think static. Okay, the linking has some issue
Only
with that, but
was
now
changed in
that
C++ 11.
that issue has been resolved. Okay, that's good.
That's good now.
Right.
But
The instead of
only Visual Studio will let you get away with it prior to C++ 11.
That's great. That's a good point. I'm just making sure you're paying attention. That this is actually not the same as the next code we will see. Well, yeah, this is too generic, and we just have integer. As long as this identity f in this slide, it's just 5 integer. This is going to work. It just captures inside an inner and returns it. Now we're going to get rid of inner and replace it with a lambda. And that's it.
Yeah.
So return that. Okay, so whole thing, return whole this thing. So what you're really saying is, well, this is a lambda, and when you put return at the beginning, you're saying, well, make a instance of it and return that, which is same as create a inner class and instantiate it and return.
Yeah.
But of course, while
Can't you
before we
capture
return it, we have to
X?
capture x. Say that again, please.
Can't you just capture X by value and return it? In the
Yes,
block?
yes, but this is a hint before we look at the complete
Okay.
code. We have to remember x, because that's what inner did, and we're still not doing it here. So how do we do that? As simple as that. So this is some new syntax you see here. This is a shortcut for saying, well, capture everything that I'm using in the body. So I'm using x. is going to make a bi-value copy of X. This is logical closure. The lifetime of this X is really short, right? Identity F is called X is 5 for a very short duration. Instantaneously, basically, you just return a closure that captures the value of X, is no longer in existence, and just returns it. So this is the pretty much the essence of the most simple example, I would say, of a closure, because it just captures something in its context. Does it make sense?
What would happen if you did something silly like on that inner closure or inner lambda, change the equal sign to ampersand X?
That will be a bad idea.
That'll be bad.
Because it's the same, classic old C++ principles. Don't return a reference to a local variable in a function. So,
Which I believe is the single significant difference between closures in JavaScript and lambdas in C++.
yeah, in fact, many languages, right? I mean, most languages, closures extend the lifetime of things that they capture. That's very useful and powerful. You don't have to think about the lifetimes. And I think that starts to get a bit sort of, I don't know, I feel a bit disappointed in C++. It's like, okay, you have to kind of keep thinking about it all the time. It's the experience of using lambdas is not so seamless. It's like, okay, capture whatever you need. You cannot quite do that because if you have a giant array.
That's because C++ is a value
Value
semantic
semantics
language.
language, that's exactly right. But then,
And trying to think about where your scope is now because you have a lambda somewhere deep inside, that would be really, I mean, trying to keep track of scope that got extended by lambdas
Sure.
would be a
If you want to do that, just make everything
Yeah.
except the overhead.
Yeah.
It's no more, it seems expensive to us because we're C++ programs, but it's no more expensive than what JavaScript does for
Absolutely.
everything.
True.
What did you
Sure.
say? Make it a what?
Just make a shared pointer or whatever it is, and then pass the pointer.
Exactly. Yeah. Do it by copy with the shared pointer and your back.
It would be,
That's
to
what
us,
it
it'd be really expensive, but it's no more expensive than what JavaScript just does for everything.
Exactly.
So, I want to say, I tried your experiment with the capital type, and it worked.
okay, pretty neat.
Good to know.
I said
No, that's-
auto, and then auto A, and then I said capital type of A, B, and it worked.
Works. Thanks. Yeah.
Very good to know.
Yeah,
So it'll force conversion if you've got.
Well, what it's going to do is it's going to force the second one into the first.
Oh, so if you do float double, you're gonna
Yes.
downcast. Ooh.
Yes. Because you can't convert the first into the second because it's not in
Right.
scope yet. And of course, you don't know which one you really want. I mean, it just does what you said to do.
No, yeah.
It makes
No,
the
that
second one the
makes sense.
same type as the first one.
That makes sense.
So, but it's going the way it's going to do it is it's going to try to cast the second into the first. It's not going to say what would be the best of both.
Right.
Right.
I guess that's what would happen if you just left them both auto.
Yes, that's what went well.
oh, yeah.
It's the best of both is two different parts. Okay, getting back here. Is this making sense now?
So
That
what
is
you've done-
actually-
what you've done over here is basically created, I mean, what's the point of the whole this thing? Is to capture some local variable and
Yeah,
extend it to
before
that?
we look into examples after these slides, I really want you to make sure that this is clear.
But what's the point? But you just captured the local variable and extended the life, is that what it is?
No, you made it so that it's
No.
now called instead of just the value.
Okay, this is, I'm not saying you're going to find some applicability of this right away in your production code, but this is probably going to exercise some, brain muscle that C++ programmers are not used to. It's like, what is happening here? You just return a lambda, a closure, and it's like prints 5 that was captured here. Now you could have 10,000 lines in between these two lines, and those kind of things. And now you have to think about, okay, capturing and using that value are two different things. When you create IDF, it's like, okay, I have everything I need, I'm ready to go, I'm ready to shoot, tell me when. And it's like, okay, now do that. And it will just do a very simple thing, just return X. Now we'll go into very interesting things later on.
But
If you've got dependent operation graphs, if you've got if you're doing something like a SQL parser, and you wanted to transform everything into, every operation into an atomic unit that could be put onto a graph so that you could schedule it across different threads or something like that, this construct actually gives you exactly what you need for that. And
Yeah, but that's a pretty, I mean, SQL parsing, I mean, it's pretty heady stuff,
I mean, we actually are in the process of seeing if we can find enough C++ 14 support to rewrite a Python-based SQL parser that does exactly that in Python to do a one-to-one conversion in C++ instead of a much more verbose function pointer or functor-based version. And basically, having the lambdas that return lambdas is a great way to essentially create a feature without the overhead of the STIP feature.
Right. So, I mean, in general, right, in functional programming, I didn't start with the theory of functional programming, that is a bit boring, quickly. You can use functions as values, right? You can use functions as data. You can pass them, you can return them, you can do whatever, you can transform them, you can do a lot of things. This is one use of it. You can return a function. We don't return functions in C++ often, but with lambdas, that's pretty much, it's a very good use of it. One good use of it. You can always pass the lambdas, but when you start also returning this, like that extends the things you can do by enormous magnitude. When you start returning functions that have captured values and things in it. So it has got some state and has got some behavior. It's like you return it, it's like, we'll get there, but that's the point I want to drive to.
Okay, just one quick one, I don't want to take too much time. So that third line that you have, return with the angle brackets equal to, if you replace that whole line, you just return x.
This whole line,
Yeah,
replace with an x.
Would
No, it's not going to work because what will happen is that its identity f is just a function that returns a value, which is x. Though we saw that function earlier, right? This is not the same as
Oh, you can't invoke it later on, okay. I see.
that. This is a completely different function.
It's returning a one, okay.
Yeah, this is returning a value and you just have to use it. Then the other one returns a function
That you can use
that you can use later on.
Got it, okay.
So I have a use case. I mean, imagine that you were working with a library and the library wanted you to pass in a function that it's going to call at a certain point and it expects you to return either true or false to know whether you continue. And you know now what the answer is when you call it. And you don't have everything in context to make a function that will actually do the calculation. You do the calculation now, and you generate a lambda which just returns true or false at the appropriate time. That's what you're doing here.
Yeah,
You-
that's
you-
a good use of it.
You have the information now, but you need to pass a function that returns the information.
Right. We're going to use this a lot in remaining slides, by the way. Return, pretty much all examples afterwards are going to return some lambda that captures something in its scope and makes it perfectly true. So that's IDF. So lambdas and closures, we looked at it early on. If you want to extend the life, you can use share pointer, we discussed that. Lambda is just syntactic sugar and I touched upon all those things. Okay, so here's another function that produces a function again that returns values in a range. So you start with this call from to 0 to 10, it's a range. And when it is called, it returns the range one by one. 0, 1, 2, 3 up to 10. Okay? It's a similar thing, you have to return something that's callable, a function. This syntax must work, and just print 0, 1, 2 as you call. So there is a state change now, right? In earlier case, each time you call IDF, it's just going to return 5, 5, 5 all the time. here it's going to do some mutating, some mutation. So again, start and finish.
I have a question, what's it supposed to do when you call it the 11th to the 12th time?
Exception.
Okay, all right.
Oh, okay.
Okay, that's that. So we have capture by value assignment. It will capture all that is necessary. It's very important. All that is necessary. Start and finish. If start is less than finish, you can start plus plus. So each time you call it, it's just gonna increment start. Note that we have captured start and finish by value. So it's essentially a class and an object which has some state, start and finish. And each time you call the operator, the function call operator, it is going to increment start. It is classic old, stateful object programming. And if start exceeds finish, it's just going to throw an exception. So are you convinced that this will actually print, return 0, 1, 2 as we call it?
So what's the reason for the mutable keyword?
Oh, good point. Sorry, I forgot that. So mutable allows you to, by default, when you create lambdas, it's going to be as if it's a const function. It does not allow you to change the state. So if you didn't have mutable over here, it is as if that operator has a const annotation. And so when you do start plus plus, it says, oops, no, sorry, you can't do that because start is a const integer, what have you, you cannot change. So now you're saying, well, okay, I'm going to change what I'm going to capture, my state. I'm going to change my state during computation. So please, compiler, make it mutable and etc. Yep, question?
I would like to put another variable in there.
Which
I
variable?
like to put a variable outside of the return or in front of the return, call it current value. And when it first
Why?
calls the first, what?
Why?
Well, I can see this, you can basically lazy Fibonacci, let's say, as an example. You call it the 13th time, and so I'm keeping my previous state, then I can, that's where I was going with this.
I see.
And this would be correct to do it that way. I mean, well,
Let me understand what you're saying. So a local variable before return.
yeah, it's right after the curly brace, you put in, auto current value, which in the first case equals start.
Okay.
And then you say return current value plus
Okay.
plus is what I would do.
Okay. All right. So what it will do is current value is equal to start, right?
Mhm.
It will make it 0 and return current value plus plus, you said?
Yes.
Right?
Instead of using
And
start
now
plus
it's
plus,
going-
I'm using current value plus plus.
current value plus plus, right? And that's the end of the function. So it's a very simple function. It just took the parameter, put it inside a local variable, did not quite increment it, it's plus plus, it just took its own value and just returned it, and that's it, that's the end of the function. It is very similar to the very first function we saw, which
Right.
returns.
But I put current value before the return, so if it's passing through the equal sign, and I'm
I'm not
Actually,
sure,
If you're doing Fibonacci, you want current value plus.
well, the two previous current values, but yeah, I would, but it's simply, instead of using start inside of your return function, I
He
would
wants
put
to
current
track
value.
something that wasn't part of the
Parameters.
parameters to the outer lambda. He wants to track something in the inner lambda that was
Okay.
passed
Current
into
value.
the outer lambda.
and use that current value in this lambda somehow.
Yes.
Yes.
Okay,
Well, I mean,
that's okay. So the question is, if you capture it by value, you just have a different state now. You have a current value.
Yeah,
state.
the naive answer would be you add it to the outer lambda and capture it in the inner lambda,
Yes.
and therefore guarantee that it is part of the immutable state of the lambda. So I think if you put it inside of the inner lambda,
Oh, that won't work. No.
it'll be initialized each time.
Yeah, that'd be correct, yes.
So
So at 14, you can do arbitrary captures.
14.
Yeah.
C++
inside-
14.
Yeah, inside your capture block, you can do arbitrary.
So could you just
Yes.
name a variable in the, where would you name it?
In the capture block, you have to say
I think that that's an advanced use
So
of
you can,
what
you
you
can,
can
you can
capture.
name a value, arbitrary value in the capture block that doesn't exist in the outer
Yes.
scope.
You can do that in C++ 14. Unfortunately, I don't really know the syntax, but I think
Does-
what you'd say is.
Is it possible to accidentally shadow something that way?
Yeah, I would guess.
Interesting, okay. But you have to give it a type and a name and possibly initial value.
No,
in
no
the
type,
capture
no
block.
type is necessary.
Huh?
No type is necessary. But I think that's an
If
advanced
you don't
topic.
have type, then you can't tell, you wouldn't be able to shadow.
An outer variable. Because you wouldn't be able to distinguish between the outer variable and the locally initial.
We're driving these.
Yeah, we're
talk
not,
off the rails.
yeah,
So-
yeah.
Yeah.
We can take that offline. I think I'm pretty much like 1 hour through from in the position slot. I want to make sure that I want to get to at least one example where there are nested lambdas, and that okay. If that trips you off, I think I succeeded. Okay. So any questions on this so far? Like this is essentially a stateful object, and yes, you are calling a simple function to increment.
If the, like they were saying about the declaring another variable right before the return,
Right before, well, I didn't get the point. I mean, you're declaring that variable or returning that variable?
declaring it, and
Okay.
then if you capture it by reference on the
by
inner
reference.
on the inner lambda,
Mm-hmm.
the state that variable lives as long as from that first
This
instance.
function lives, exactly, that will
So
be
that
added.
variable will still live, okay, correct.
That will be lost. Yeah, it's a dangling reference essentially, which is, it's going to crash your program eventually. So you definitely don't want to capture state in a, in a lambda that's inside a function by reference. That's
Not if
That's
you're
going to
returning
be-
lambda out of the function.
not unless, yeah, if you're returning that function, lambda, exactly, thanks.
If you're
returning
keeping
it,
the lambda local to the scope, it's fine.
makes sense.
The critical thing is that the scope of whatever you're capturing by reference has to be greater than the greatest scope that that lambda will exist in. The lambda cannot be passed outside of the scope of any values that is captured by reference.
Yes.
Again,
No different from pre C++
Yes.
11.
if this is a lot of syntactic sugar, then I want to think about the inner class that we looked at, that created a class within the function, had a constructor, had an operator or something, and it just pushed values in it and returned an instance of it. That is exactly what's happening here. For a type, some unpronounceable type is created. There is a constructor for that. That constructor will take two things, start and finish. So now you have that state and one function in it. That's that. And all the rules that will happen with that class, anything that can happen with it, is also applicable here because it's not.
I would note that stylistically, this is obviously intended for integer types. Although the lambda syntax would work for an iterator, the fact that you're post-incrementing and using a less than comparator instead of not equal.
Oh, this is just an example. I mean,
Right, I'm
think
just saying-
why it's just
But
the
one-
state. I know where the state lies. I want to bring that up. Say
Right.
the state lies inside this guy, and it was produced by this. No question.
In the inner capture square brackets, equal to sign, what other things can you put in there?
Square bracket equal
The
to
capture,
inside that.
yeah, the equal to.
Okay, equivalent to that would be put in start and finish inside that bracket, separated by comma. Start,
What if
comma,
you have
finish.
the equal to sign completely? Would you capture everything by default?
Okay,
By default, what's the default capture?
No.
default capture just opens square, open and close brackets.
I don't think it
It's not
captures.
going to capture anything.
Yeah.
That's nothing, that's right, okay.
If you have equal, it's going to copy everything by value. If you have reference, it's going to, it's going to capture everything by reference. You can pass a list of parameters. The C++ 11, you can pass a list of variables that exist in scope using reference or not for each one. So anything you don't say reference will capture by value, everything you say reference will capture by reference.
It's just,
And apparently C++14, you can even add an arbitrary new
New state, yes.
value
It
to
gives
that.
you
They
better
added
control
that
of the state.
Because there is no way, without that, there is no way to move into a capture.
Yeah.
Oh, that makes sense,
You can
okay.
either do it by reference or you can do it, but you can't do it by
You have to
formula.
say explicitly.
Right.
When you move,
Okay.
you have to say that you want to do that, and that's why you need a syntax to
Gotcha.
say that.
Gotcha. So you use the same thing to, for example, take a shared from this object and capture the shared pointer to it. Which
Yes, you can do that. You can capture a shared
Would-
pointer.
would-
Well, I
would
don't
be
know.
very useful.
No, I'm not
for
sure
some-
if you can
for-
capture shared pointer because you don't specify type when you.
No, it just calls out shared from this. Local variable dot shared from this. I'm wondering if that would work.
Okay. Yeah.
I'm gonna have to try that because somebody came to me with a problem that would actually solve last week, so.
Any more questions? Okay, moving on. Okay. So now write a function that adds two things in two invocations. So add f is a function, okay, clearly it takes a parameter. When you call it, it returns another function. Well, you can call it again. Here it is. You call it twice. I mean, call it. Here is another function. So you can call it. And in two steps, it has to capture 5 and 4. Right? It's like saying, well, it's add, right? Add takes two, add needs two arguments. It's like, okay, give me the first argument. I know what to do with it, but I cannot do much with it unless I know the second argument. So I'll keep it with you. And I'll wait patiently for you to give me the second argument. Till then, I'm just in the ether doing nothing, essentially. I'm just patiently waiting for my next argument. And how do you give that next argument? Well, in this case, I do it right away. I could split into two things and do it in two different times, but here it's just 5 and 4. It's crazy, I agree, but I want to think about that, okay, when you call a function, you can specify arguments one by one. That is so counterintuitive and so sort of, it's like, why would you even do that when C++ allows you to pass, I don't know, like variadic things, like we want to pass 15 arguments at a time, why would you shrink it down to one argument? But that's very powerful, we'll look at that, what it's called. But here it is, how will you do that? Go ahead.
So just to make sure I understand, the first time you invoke it, it's going to return a lambda that you're going to use for the second invocation.
That's right.
It's not just that you call the function twice.
No, you are not calling the same function, absolutely
Right.
not. This is a complete invocation of a function called addf. And
It's
this
a
is
fixed number of function call operators that you get with it. It's not like an arbitrary, like there are libraries that have, tricked out things so that you get dot, or you get like multiple parentheses in a row that actually are just, an arbitrary length of them.
Is this analogous to function chaining?
It's function chaining in a manner of speaking, because the function creates another function that then gets executed, but it's a fixed depth, so it's not chaining.
yeah, this specific example is not intended for that.
Although-
the thing I want to do here is this: you can capture the state and in steps. You don't have to do it in one shot. Use add in one argument at a time.
You could actually make the first parameter the number of remaining parameters, and then
Probably not,
No,
because
you could.
syntactically that's going to be pretty challenging.
no, you can do it. I'm
Maybe
really certain of this.
I can see a lot of applications for this, but I just want to see if it is conceptually very similar to function chaining or different.
Mhm. So let's look at the implementation. Okay, there we are. No, it's still not, yeah, it's a nested lambda, fine. I think we didn't use it. two limits. So let me know if you're not convinced that it's going to say, it's going to do what I just said.
That's gonna return.
Yep, question?
So when it will capture, for example, I'm calling ADDF 5 in a bracket, and then one bracket will be empty, right? First time when I call, or I have to call in this way.
Exactly like this.
It's okay.
I think I'm only missing this vehicle.
Okay. But when you say that, right? For example, it will wait for for you to kind of give a second value, right? But if I have, for example, 10 or 1,000 line of code in between two calls, how can I do that?
Well, by not putting this first of all.
Okay. It's a whole bracket will be not
This
there,
thing
right?
will be gone, yes. Because the moment it gets everything it needs, it's going to fire.
Right.
It's like, okay, I got everything I need, I'm gonna do this. Okay. So you don't put this bracket and pass anything. Don't finish all it needs. Whatever this guy returns, keep it around as long as you want.
Okay.
And then you can essentially, you can think of a loop, okay? A loop that always adds 5 to an integer, okay? So how will you do that? We'll use add and we'll sort of partially split, partial application, that's what it's called. We'll specify the first argument, okay, 5, and then whatever you pass in, imagine a loop around this, and I here. It will just, okay, I0, 1, 2, 3, 4, it will just keep adding 5 to it, because that's all it knows. It's like, I have 5 with me, the only thing it can do when you give a second integer, it's like add 5, add 5, add 5.
So when we call the first time, we have to handle that as a lambda function, right? Auto add or something, right? Do we need to handle, or is when we call only for
Yeah,
first
you will
time?
need to do that. Yes, you have to split, to get rid of this,
Yeah.
auto add 5,
Okay.
okay, or as long as you have 5 here,
Okay.
and then pass in,
So when we call the same function next time, I have to just give a 4, right?
yes.
Okay. See.
So, just something may help in reasoning this. These curly braces are, the program hits those curly braces in reverse order. That might help you get what's really happening. So over here, add f is called, and then it returns something. It clearly didn't execute this. It hit this closing brace first, because it's kind of it exited from here. That's this part, that's what this part did. And now when you do the whole thing, now it jumps in. It already has captured x through this assignment. It gets the remaining piece it needs, y, and now it is going to do addition, x plus y. And only then it will hit this inner bracket. So your goal is, well, the brackets are, you exit from these brackets in reverse order.
The lambda returns a function object. The function object's not going to do anything until you call it. So that's kind of the point. So the addf returns the function object. If you give it 5, well, now it's basically waiting for the second parameter to the inner lambda before it'll ever fire. Once you get that second one, then it'll fire the internal one to return the external one. So you're just getting function objects waiting to be invoked, essentially.
That's right. It is waiting for remaining pieces.
So would you say that using equals is equivalent to other languages where everything is captured by default and you don't have to specify explicitly what to capture?
Most languages are
I
actually
would
equivalent to that,
use
used as a reference.
Equivalent,
Oh, the
because
reference.
it's by reference.
Right.
In fact, it is definitely not equivalent, because in other languages, you will not have this piece. First of all, the whole thing is not there. It will extend the life of x itself.
Right.
It's the same thing that you're looking at. But here, x goes away, and you have a copy of x with you. Although you just reference it by the same name, but it's a different memory location altogether.
Gotcha.
Okay, so when everyone's convinced, how about this? A function. So all the examples earlier were pretty straightforward. So now we'll start doing some interesting transformation per se. So a function swap. Now you pass in a function, by the way. The operation itself is passed in. So that we will parameterize that. And swaps the arguments of the binary function. So whatever binary function you pass in, well, add is kind of weird, it doesn't make any difference, but subtract, right? 3, 2. If you call subtract 3, 2, you're going to get 1. You just call it, you just get it immediately. When you pass it to swap and do it this way, swap is interesting. It says, well, I want to swap these arguments so that it's going to do 2 minus 3, and I want to get answer minus 1. Think about it for a minute. And by the way, I'm past my allotted slot, I believe. It's like 90 minutes, till 11. And the next presentation is 11:15. So I'll be happy to continue till 11:15, in fact, as long as you guys want. But I'm just letting you know that next talk is coming up in less than 15 minutes.
The next C++ talk is going to be in 4201. It's going to be Greg Law talking about reversible debugging. And I need to run off to it, but thank you very much.